Have you ever felt like talking to a computer means learning a completely alien language? Well, yeah, because it kind of is. But what if you could get your ideas across not with lines and lines of text, but with visual blocks you can just click together? Today, we're going to pull back the curtain on visual programming, an approach that's opening up the world of software development to, well, pretty much everyone.
Okay, let's just cut right to the chase. Over on the left, you've got traditional programming. It's a wall of text, right? It can look pretty intimidating. Now look to the right. That's visual programming. It's more like a flowchart or a map. You can instantly see how one thing leads to another. That is the huge difference we're going to dig into.
So yeah, let's explore these two very different paths we can take to tell a computer what to do. One is all about text, the other is about pictures. They both get you to the same destination, but the journey is completely different.
So what is visual programming, really? At its heart, it's pretty much what it says on the tin. It's a language where you build programs by moving around visual things. You're dragging blocks, you're connecting dots, you're arranging icons. You get to focus on the logic of what you're building, not on whether you forgot a semicolon somewhere.
And you know, this isn't some new fad. The core idea has been around since the 60s. But the game really changed when we all started getting computers with graphical interfaces. Think about Apple's HyperCard in '87 or Microsoft's Visual Basic in '91. Suddenly, regular people could build actual applications visually. And if you fast forward to today, that spirit is alive and well in tools like Scratch, which is teaching millions of kids how to code. It's amazing.
All right, let's step into the workshop. When you're doing visual programming, your main space is called the Integrated Development Environment, or IDE. The best way to think about it is like a digital workbench, already stocked with all the parts and tools you're going to need.
The most basic parts in your toolkit are called controls. Honestly, just think of them as digital Legos. They're the buttons, the text boxes, the labels, all the things your user is actually going to see and click on. You literally just drag them from a toolbox and drop them right where you want them.
So you've dropped your Lego block onto the screen, but how do you change it from a red block to a blue one? That's where properties come in. Every single control has a list of properties: its color, its size, the text written on it. This is how you design the entire look and feel of your app.
But, you know, a pretty button is just a pretty button until it actually does something, right? That's where events kick in. An event is just a signal, a notification that something happened. The classic example, a user clicking a button. That click is the event, the trigger that tells your program, okay, go time, run the code I told you to run.
So we've got our building blocks. We know how to make them do things. Now we get to the really cool part, teaching our application how to think for itself. Because really, all programming boils down to making decisions. It's about looking at a situation and choosing which path to take, just like a fork in the road.
Which brings us to the big question, right? How do we actually build those forks in the road? How does a program look at a piece of info and decide, okay, based on this, I'm going left, not right?
The answer is a simple but incredibly powerful tool called the if, then, else statement. It's the bedrock of decision-making. All it does is ask a simple yes or no question. If the answer to the question, the condition, is true, it does one thing. If the answer is false, it does something else. That's it. Let's make this super clear with an example we can all get. Checking a test score. The program asks one question. Is the score 50 or higher? If the answer is true, boom, it prints pass. If the answer is false, it prints fail. It is that simple. And that basic if this, then that logic, it's the foundation for almost every complex decision any piece of software makes. Okay, but what if you've got more than two choices? Like you're not just doing pass-fail, you're assigning grades. A, B, C, D. You could chain together a bunch of if-then statements, but that can get messy real fast. So for these situations, there's a much cleaner way, the select case statement. You just tell it what you're looking at, the grade, and it neatly handles all the different possibilities. It's just so much easier to read. So we've got the pieces, we've got the logic. Now let's answer the big so what question. Where is visual programming actually being used out there in the real world? Where is it making a difference?
Oh, it's everywhere once you start looking for it. In game development, huge engines like Unity and Unreal use it so artists and designers can create complex game logic without being expert coders. In education, it's a total game changer, teaching kids computational thinking with tools like Scratch. It's also essential for building app prototypes really fast and for programming all those little smart devices in our homes.
Now, it's super important to know that it's not a magic wand for every single problem.
The upsides are obvious. It's easy to get into, it's way faster for getting ideas up and running. But there's a trade-off. For gigantic, super complex systems, like say the entire backend of Google, you might start to bump up against limits in flexibility or raw performance that you wouldn't have with traditional code.
So let's just zoom out for a second and take in the big picture. Visual programming isn't just another tool in the toolbox, it really represents a whole different way of thinking about how we build the digital world around us.
So what's the big takeaway for you in all this? Well, first, it helps you understand the core ideas of programming in a way that just clicks. It gives you the power to build your own stuff fast. And maybe most importantly, you're building these incredible problem-solving skills that serve as the perfect on-ramp to text-based coding, if that's where you want to go next. And all of this leaves us with one final big idea to think about. By lowering the barrier to entry, visual programming is empowering more and more people to be creators, not just consumers. So the real question is, could building our digital world, the next big app, one day feel just as easy and intuitive as playing with blocks?